Variation
Should I
of
mute
pressure.
myself?
Yes, you can. So this variation of pressure, this is a very basic concept in fluid dynamics, or you can say fluid mechanics. Okay, so you must understand it very carefully. Okay, this is the most fundamental block of fluid dynamics, or you can say fluid mechanics, all right, or fluid statics. So let's understand variation of pressure, how pressure varies inside a fluid. Okay, all right, so let's begin our discussion on variation of pressure. All right, so let's take a vessel which consists some amount of water. So this is water, and the height of this vessel is h. This vessel is completely filled. Okay, right now. Now let's take an element over here. Okay, its height is dh. All right, and let's say its area is a. All right, what other thing we must understand here? First of all, let's say this is point a, or let me make it small a, and this point is b, small b. All right, let's say pressure p is being acted on this surface, this upper surface. So that means from this bottom, on this bottom surface, the pressure would be P plus dP. As you know, as you go deeper, pressure increases. That's why here the pressure is P plus dP, and here pressure is P. All right. Now let's balance force on this element.
Sir, before that, what is DP here?
Here dP is pressure. Okay.
Okay, the extra pressure.
Yes. So force balance on element. So on this element, how many forces are acting? First, due to this pressure, and second one due to this pressure. We are right now not considering uh, its weight force or anything. Okay. So yes, I mean we will consider here the weight force which will act in downward direction, right? Which would be dmg. Let's say the mass of this element is dm. So this dmg is being balanced by these two forces, which is P multiplied by its area minus P plus dP multiplied by its area. Yes or no? Let's call it equation number 1 and then proceed. So right now this is a difference, so it doesn't make, I mean, if you write it this way, that P plus dP multiplied by A minus PA. So since we need only difference, so it will be okay if you end up with a negative result. Okay, so that's why I swap its position. Okay, it's all right, you can do it because it's a pressure difference. Okay, so as you can see, this PA will cancel out each other, so we'll end up with dP multiplied by A is equal to, we can write this mass in terms of density, that is uh, first of all, density is given by mass upon volume, which is m by v. Here the volume of this element would be uh, this height dh multiplied by its area, right? So from here you can find out the dm mass, which would be rho multiplied by v, and since volume is dh into air, so here mass would be dha rho. So just plug this value here. It will become rho a dh multiplied by g. You can actually cancel out these areas. So we'll end up with dp is equal to did we miss anything or what? Rho dh into g, right? We forgot this g. This g. Now you can integrate it from point A to point B. That is our bottom point, right? So if we integrate over these 2 points, I mean we are actually interested in finding out the pressure difference between this point A and this point B. So it will be from point B to A or A to B. So it will be PB minus PA is equal to, here height is varying from 0 to h, 0 to h, because that is the height of this liquid or this vessel. So it will be rho g h. So that's how we'll end up with this result, this formula. Okay, very important formula, that as you go down deeper and reach the bottom of this vessel, the pressure at the bottom of this vessel is given by rho gh, or you can say the pressure difference between an outside point and a bottommost point is given by rho gh. So this is how a pressure varies inside a fluid, okay, of height h. Are you getting my point?